Welcome to another session by Scholarden on GRE Quant. We are going to be continuing on some of the topics that we had covered earlier, and we are going to look at the others in detail. So far, we had looked at the Cartesian plane, the XY coordinates, the equation and the forms of equations of a straight line. And lastly, we looked at how we could find the distance between any 2 points if they are shown on an XY plane. So today we are going to build on these and start with some of the more advanced topics or advanced aspects of how or these topics could be used. Okay, so the first thing that we are going to be doing is shifting lines. So if we had a straight line, the equation of a straight line, and we were asked to shift it either along the x-axis or the y-axis, how would we do that? Then we are going to look at how we could find the points of intersection of two lines. And then finally, we are going to look at how we can find out if a point lies on a line or not. Okay, so without further ado. So first of all, let's say we have this line, okay? As always, we'll start with the XY plane, okay? So we have this XY plane and we have this line, right? Okay, so let's assume that this line passes through the origin, right? And the question is, first of all, and I want you to think about this, what's going to be the equation of this line, or how is it going to look like? So in the standardized form, in the slope-intercept form, what is the equation of this line going to look like? So I'm just going to give you, let's say, 5-10 seconds just to, for you guys to refresh some of the things that we discussed earlier. And okay, so what is, again, let me repeat the question. If this is a line that is passing through the origin, okay, so this is slightly deviated, but let's assume that this is passing through the origin. So if this line was passing through the origin, what is its equation going to look like? Okay, so its equation is going to look like y is equal to mx. And why is the c going to be 0? We discussed it earlier that if you have a c, then the y-intercept becomes non-zero, right? So for it to be passing through the origin, this c has to be 0, okay? So this is going to look like y is equal to mx plus c. And now suppose that we are required in a question that we want to shift this line upward along the x-axis. So we want this line to be somewhere over here. It's the same line, okay, but shifted upwards. Okay, so previously this was passing through the origin, and now this is passing somewhere over here. So what is, how do we find out what is the shifted form of this equation? I'm just going to quickly, based on this figure quickly, think about this and see that if this was one line and this was a different line, so how is the equation of this line that is shifted upward along the x-axis, going to differ from this line, the original line over here? Right, so what we can see is that over here, the y-intercept was 0, and that is what got us this form of the equation, right? So y is equal to mx. We got this equation just because the y-intercept was 0 over here, right? So, and now what we want is that the y-intercept should no longer be 0, but it should actually be a positive value, okay? So if it was supposed to be a positive value, what are we going to do? We know that there is, in the, the slope-intercept form, we've got something like this, okay? And so what is this c over here? This c is actually, because originally this line was, passing through the origin. What this c tells us is the distance that the original x-intercept was, and this new, and is the difference between the original x-intercept and the new x-intercept, right? So if c is this x-intercept, so what is this going to tell us? That this is actually c. If this, for example, c2 is the new intercept and c1 was the old intercept, so this is going to be c1 c2 minus c1. And if this value is positive, c2 minus c1 is positive, you're going to be shifting your line upward along the y-axis, right? Conversely, let me just draw another line. If we wanted to shift the same line, we're not changing the slope, but if we wanted to shift the same line downwards, right, along the y-axis, okay, what is its y-intercept going to look like? So for this line, okay, the equation is going to look like mx plus c2 minus c1. The only difference being over here, c2 is less than 0. Why? Because we are moving the line downwards, right? As we said, we wanted to shift this line downwards. So over here, c2, this new y-intercept, is going to be less than 0. Okay, so this is less than 0. So any number less than 0 minus 0, so this value, this y-intercept in its entirety is going to be, sorry, let me draw it the other way. So this is going to be less than 0. So this y-intercept is going to be less than 0. So to summarize, if we wanted to shift a line upwards, let's say if a line was passing through the origin, and if we want to shift the line upwards along the y-axis, you're going to just add what is the amount or how many units we need to shift the line upwards. So this is going to be your C. And the C you can find out by subtracting the new x-intercept with the old x-intercept, okay? So let's quickly take a look at one example, okay? So let's take a look at one example in which we are going to have to shift the line upwards, okay? Let me just quickly erase these. Okay, so we have, let's say, this x and y coordinates, okay? And we have this line passing through the origin, y is equal to 2x, okay? And if the question asks that you're supposed to shift this line upward by 5 units along the y-axis, so what is its new equation going to be? So if we shift the line upwards, okay, by 5 units, so what is the new equation going to look like? Right. So the first thing is that we understand that over here, the y-intercept is 0. Okay. So over here, C1 is 0, and we want the new y-intercept to be 5. So because the slope is not changing, we are simply shifting the line upwards. So what we are going to do is we are going to do the standard thing. We are going to write y is equal to 2x for this new equation. And then we're going to see that what is your new y-intercept going to be? Why we know this new y-intercept is going to be? Because we know that this line was originally passing through the origin, and now we just want this line to be shifted 5 units upward. So obviously the y-intercept is going to be 5. So the new intercept is going to be 5 minus 0. So the equation of your line is going to become 2x plus 5. So this is your equation. This is your equation, right? Conversely, if you were supposed to shift this line, say 5 unit downwards, okay? So in this particular case, your equation is going to look like 2x plus, what is, C2 over here? C2 is minus 5, right? Because this is your new y-intercept. And this is going to be minus 0 because this is your original y-intercept. And this is going to be y is equal to 2x minus 5, okay? So this is going to be the equation for the line that is shifted downwards. Let's take another example in which our reference line is not on the origin, but it is, slightly offset, okay? Let's assume that the line does not pass through the origin, but it is already shifted upwards or downwards somewhere, okay? So here is your, the intersection of your axes, and your original line is passing over here. Let's assume that the equation for this line is going to be, first of all, can anybody guess what is the slope of this line going to be? Whether it's going to be positive or negative. So as you might have guessed, because this is going upward, okay, so the slope is going to be positive, right? So let's assume that the slope is simply x, okay? The slope could be 1, could be 2, could be 3, any number, but we are assuming that the slope is 1 over here. Okay, and let's assume that this intercept is 4. Okay, so this is x plus 4. So this is the equation of this line, which is y is equal to x plus 4. And now what we want to do is we want to shift this line 5 units downwards, right? So the new line is supposed to be somewhere over here. Okay, it's going to be somewhere over here. Now, the first thing is that we can find out that the slope isn't changing. So the first aspect is going to be the same. So y is equal to x. And now the question stated that we wanted to shift this line, which had a y-intercept of 4, 5 units downwards, right? So 5 units downwards, we want to shift this line 5 units downwards. So we know that this distance over here, this is 0, and this is 4 along the y-axis. Why? Because the y-intercept is 4. So we know that this is 4. And because, so if we wanted to move 5 units downwards, what we're going to do is we're going to traverse 4 units downwards along here. So we reach the origin, and 1 more unit over here. So this is -1, right? So this point is -1. And so now what we know is, because in the slope-intercept form, the next part for this line comes as the y-intercept. So over here, what we are just going to do is add a -1 to this expression, and this is going to be our new, the equation of our new line, which is shifted 5 steps downwards. Okay, so I hope that this is, why I'm covering this is because such concepts come in really handy when you're discussing GRE. As I said earlier, it's time compressed. So what we want to know is that these concepts are really, these concepts come in really handy when we are supposed to answer different questions. Okay, so here's another question. Okay, we've seen that, for example, we can shift the line up and down along the y-axis. So what happens if we are asked to, for example, shift the line along the x-axis? So assume that you've got this line, okay? And this line passes through your origin. So let's say this is just y is equal to x. And now we say that we want to shift this line, let's say 3 units along the x-axis, the 3 units towards the right along the x-axis. So the first thing is we want to understand what this intends. So we want to shift the line 3 units to the right along the x-axis. Okay, so if we are supposed to do that, for the first thing that we want to understand is that what this entails for this line. So if you're just looking at this line, we understand that what is the x-intercept for this line, because this is passing through the origin. So the x-intercept for this line is 0. Okay, and so now what we want to do is we want to shift the line 3 units to the right. Okay, so if we move this line 3 units to the right over here, what I've just done is I've just moved this line from here to 3 units to the right. Okay, yeah, exactly. But this is we're just going to see, we're not going to add directly over here. So this is 3. So first of all, what we understand is that the x-intercept for this line, okay, is going to be 3. Okay, so now let's look at this equation. Y is equal to x. Okay, so what happens if we just add 3 over here? Is it going to be correct? Let's quickly think about this. Is it going to be correct if we just added 3 to this equation? Yes. Why is this going to be wrong is because, let's say we want to move the x-intercept to x is equal to 3. But if we were supposed to add plus 3 over here, let's calculate the x-intercept for this. We plug in y is equal to 0. So 0 is equal to x plus 3. and we bring in 3 to the other side. So x is equal to minus 3. So this equation, what this equation is actually doing is moving this line to the left. So instead, what we want is that our x-intercept should be positive. So in this particular case, what we can find out is that this is going to be y is equal to x minus 3. This is a special case because the slope is the same. So this is because we've started from the simplest case, which is y is equal to x. If the slope was changed, if the slope was, say, not unity, it was, either 2 or 3 or 4 or -2 or -3 or -4, then we'll have different, and we're going to look at that. We're just going to quickly look at that. So first of all, so this is, our equation. And how does this satisfy this condition? Is because if we want to now, calculate the y-intercept for this, x-intercept for this, we plug in 0 over here. So 0 is equal to x minus 3. You bring minus 3 over here, and you get x is equal to 3. So this equation satisfied this condition, right? Not the other way around. And so this, this equation also tells us that if we add to the y-intercept, you're going to shift your line to the left as well. So this is for the simplest case in which the slope is the same, okay? I'm going to, for example, keep the condition the same, okay? I'm going to keep the condition the same, but I'm going to change to a different line over here. So for example, we have a different line. We have a line which has an equation of, say, something like this. So this is not passing through origin. Okay, let me explicitly state that this is not passing through the origin. And this is, let's call it y is equal to 2x plus 1. Okay, so this is the equation, y is equal to 2x plus 1. And now what we want to do is we want to shift this line 3 units along the x-axis. And now we want to find out the equation of the new line. Okay, so first of all, what we want to find out is that what is the x-intercept for this line? Okay, let's start from there. What is the x-intercept for this line? Okay, in order to find out the x-intercept for the original line, let's just say y is equal to 2x plus 1. We plug in 0 over here. So 0 is equal to 2x plus 1. We bring over here. So yeah, there's, I drew the line slightly wrong. So let me just quickly correct it. So this is y is equal to 2x minus 1, okay? So that is going to satisfy the figure on the graph as well. Okay, so y is equal to 2x minus 1. We bring in 1 over here. So 1 is equal to 2x. We divide both sides by 2, and we get x is equal to 1 by 2. So this point over here, this is x is equal to 1 over 2. Right? Okay. And now the question states that we want to shift the line 3 units to the right along the x-axis. So what this means is that our new x-intercept is going to become, can somebody take a guess? So our new x-intercept is going to become, the original x-intercept was x is equal to 1 by 2. So the new x-intercept is going to become x is equal to 1 by 2 plus 3. And why 3? Because we are supposed to shift the line 3 units to the right. So the x-intercept is going to increase. Okay, so now let's quickly find that out. Okay, so x is equal to, let's take the LCM. So 2 plus 3 times 2 is 6. So you get 7 by 2. So your new x-intercept is x is equal to 7 by 2 or 3.5. Okay. So your new x-intercept is x is equal to 7 by 2, okay? And now how are we going to do that? X is equal to 7 by 2, okay? Your original equation was y is equal to 2x minus 1. Okay, so here's the thing. We understand that if we plug in y0 over here, okay, so what is going to happen is this, whatever this value is, this is going to come over here, right? So this is going to become positive 1. And then when we divide both sides by 2, so we're going to get 2 in the denominator. So we're getting this part, okay? We've just seen that we're getting this part. So Yes. Okay. So I hope that I've rectified, the equation as well. So let me just quickly tell you what I was doing. Okay. So the equation of the line over here is, this is our new line. Okay. Let me quickly complete the figure. Okay. So this is the equation that we want. We want the x-intercept to shift to the right by 3 units. The original equation was y is equal to 2x minus 1. Okay. So the new intercept has to be x is equal to 7 by 2. So this is the x-intercept that we want. Okay. So once we plug in 0 over here, this is the equation that is going to, be left with us. This is 0 is equal to 2x minus 1. Okay. And now what we do is we bring this 1 over here, minus 1 over here. So this is going to become 1 is equal to 2x. Okay. And once we divide both sides by 2, we're going to be left with x is equal to 1 by 2. But instead, what we actually want is, so, okay, let me just take a step back. Once we divide both sides by 2, we are going to get 1 by 2. Okay. So we're going to get 1 by 2. So this is the same thing. Okay. So without doing anything, we've gotten the denominator, but the numerator is different. Okay, so the numerator over here is not the same. We want the x-intercept to be 7 and not 1. So where did this come from? This came from when we brought in minus 1 from the right-hand side of the equation to the left, right? So if we had instead brought in 7, what would we have done? Okay, if we had a minus 7 over here, what would have happened is once we shifted this minus 7 to the left-hand side of the equation, we would have gotten 7 over here. And once we divided both sides by 2, we would have gotten x is equal to 7 by 2. So now the equation of the line that is shifted 3 units to the right becomes y is equal to 2x minus 7, because for this equation, the x-intercept is 7 by 2, which is what we had wanted earlier. Okay, I hope you got this. This is a bit of a roundabout way of doing this. This is not as straightforward as, say, when we were shifting along the y-axis. But what I wanted to convey to you is that whether we want to shift the line along the x-axis or the y-axis, we can do that both ways. Okay, so let me quickly recap. Okay, for some of us who might still face some, let's say, difficulty in this. What we want is we've previously seen that we can shift the line upwards, right? We said that in the slope intercept form, all we need to do is find out what is the difference between the two intercepts, or we can find out the difference between the two intercept, or we can find out simply the distance that we want to move our line up or down. Okay, and that is one way of going about this. But for this particular case, there's this slightly different. Okay, let me quickly redraw. Okay, so now we have a line. Okay, we have these xy coordinates. Okay, and we have a line, say this line. Okay, and this line is equal to y is equal to, I'm going to go simpler this way, y is equal to x minus 2. Okay, so what does this tell us? If this is y is equal to x minus 2 line, so y is equal to x minus 2, so its x-intercept is, we bring 2 to the other side, and x is equal to 2. So this point, this x-intercept is x is equal to 2. And now the question requires us to do what? Let's say we want to shift this line, say 2 units to the right. Okay, so we want to shift this line, this y is equal to x minus 2 line, 2 units along the x-axis to the right, because when you're moving along the y-axis, you go up and down, and when you're moving along the x-axis, you go left and right. Okay, so now what we want to do is we want to shift this 2 units to the right. Okay, so let's say this is our new line, because this is what it's going to look like. So this is, you shifted 2 units to the right. we don't know what this x-intercept is. Okay, we know the original x-intercept, but we don't know what this x-intercept is, right? So the first thing is that this line, because the slope isn't changing, so this is going to look like y is equal to x. Okay, so y is equal to x will remain, but how do we find out this new x-intercept? We do that again with the same method. Okay, if we had this original equation, let me just quickly change the color of it. If we had the original equation, y is equal to x minus 2, okay, so what is its x-intercept going to look like? Its x-intercept is going to look like x is equal to 2. How do we do that? We first plug in y is equal to 0, and we bring in minus 2 over here, so this becomes plus 2, okay? So this is the x-intercept. And now the question tells us that we want to shift this x-intercept from here to 2 units to the right to this new point. So if the original x-intercept was 2, where does it take us if we shift this point 2 units to the right? This gets us to 4, because 2 plus 2, this is the distance that we are supposed to move, and this is your x-intercept. So 2 plus 2 is 4. So the new x-intercept is going to be x is equal to 4. Okay, so this is the new x-intercept. Okay, and if we look at this equation over here, so what we really wanted was that instead, once we plugged in y is equal to 0 and brought this number from the right-hand side of the equation to the left, instead of getting a 2, we should have gotten a 4, because our new x-intercept is actually x is equal to 4 over here. Okay, so what we really wanted was, instead of having to move 2 over here, we should have been moving 4 for the new line. Okay, so over here, we just write 4. Okay, we just write 4. And if we do the same process, we get this new x-intercept is as x is equal to minus 4. And if this is only possible if we take this back, okay, if we move it back, so 0 is equal to x minus 4, and we know that, for example, 0 is this value which we plugged in instead of the y, so we really get y is equal to x minus 4 for this line that was shifted to the right. Okay, so no, here's another thing that comes as an extension to this. So first of all, we've seen that we can, for example, say, shift the x-axis or the y-axis. So sorry, the line along, we can move the line along the y-axis upward or downward, or we can move the line left or right along the x-axis by playing around with this intercept, okay, because we're not really changing the slope over here. But here's another thing, okay, over here what we did was, this is, just take a look at this line, okay. For this line, what we did was, we are just asked to move this line 2 units to the right. So what we did was, we moved this line 2 units to the right. And look at what happened to the y-intercept. The y-intercept changed accordingly, okay? And now if we look at this equation as well, which is the equation that we got after shifting the line towards the right, we see that the new y-intercept, the original y-intercept was y is equal to minus 2. Why so? Because we plug in x is equal to 0, and so y is equal to minus 2. This is your y-intercept for this original equation. But when we have shifted our line 2 units to the right, what is your new y-intercept? We plug in 0 over here instead of this x, and so we get y is equal to minus 4. So the intercepts change. So the point that I want to convey is that the intercepts change. When we are moving the line left or right, both intercepts are going to change. So here's a quick example, okay? So let's say this is your line that passes through the origin. First line, we move upward. See, the y-intercept has changed, but also the x-intercept has shifted from this point over here now. Okay, if we moved it downward, if we shifted it downward, okay, now the y-intercept has shifted from this point, okay, over here. But the x-intercept has also shifted from this point to this point, okay? The same is the case when we are moving the lines or shifting the lines either left All right. So if we were, for example, shifting, a line, say along the x-axis, whether to the right or to the left, what's going to happen is, let's say if this is the line, this is the original line, okay, and we're supposed to shift it with certain units to the right, then see over here, we have changed the x-intercept, the new x-intercept is over here, but the new y-intercept has also changed. Okay, and if we shifted the same line, somewhere back, okay, over here, what we're going to do is we have changed the x-intercept from this point to this point, but we have also changed the y-intercept from this original position to this new position, okay? So when you're shifting the lines, understand that it's not only the one intercept that is moving, it's both intercepts that are going to change. Okay, what is important is for you to realize this. So some question in the GRE is going to ask you something like this. So for example, if you have a line, okay, let's say, I'm just going to quickly write this down so that I can actually move forward. Y is equal to 2x minus 5, okay? And if we shift this line 4 units along the x-axis, okay, what is its new y-intercept going to be? Y-intercept going to be? Can somebody quickly ponder upon this? Okay, we're not going to solve this. We're going to look at some of these questions later on. There are some planned, but I just want to for you to realize, what is being asked. You're given the equation of a line. The first thing is that, the math shouldn't scare you. Okay, it doesn't matter if the line is y is equal to 2x plus 5 minus 5 or anything, whether the slope is in fraction, whether the x or y coordinates are fractional, doesn't matter. What matters is, first of all, you have to revert back to fundamentals. What is being asked of you? What is being asked of you is that you're given a line and you're being asked to shift the line, 4 units to the right along the x-axis. Okay, we know that. We know that the simplest way to do that is to first of all calculate the x-intercept for the original line, and then we add the distance by which we want to change the x-intercept, which in this case is 4. Okay, and then we kind of find out the equation for the new line, right? So if we can do that, if we find out the equation for the new line, then what is remaining? The only thing that remains for us to do is that all we need to do is that we just need to find the y-intercept, okay? Let's just quickly solve that, okay? You have this equation, y is equal to 2x minus 5, and you're supposed to shift it 4 units, shift 4 units to the right along the x-axis. Okay, so let's do that quickly. Right. Okay, here we go. So first of all, we find out the y-intercept for this. What is the y-intercept for this is going to be? Can somebody help me? Okay, so if you plug in y is 0, so 0 is equal to 2x minus 5. Okay, right, that's great. Yes, exactly. Okay, we bring in 5 to the other side. We are left with 2x. We divide both sides by 2, and we get 5 by 2 is equal to x. So the x-intercept for your original line, okay, that's great. Some of you have already done that. That's wonderful. But for the others who are still, following me, let's just quickly complete the solution. So the x-intercept for this original line is x is equal to 5 by 2. Okay, and now what we want to do is we want to shift this to the right. So we want to increase this x-intercept from 5 by 2 by 4 units. And what this is going to look like is, for the new line, x is equal to 5 by 2 plus 4. And we take the LCM. This is 2. So this is 5. And this is going to be 8 because, 4 by 1, right? So this is the new x-intercept. Okay, so the new x-intercept is x is equal to 13 by 2. All right, okay. Now let's look at this original equation. The original equation was y is equal to 2x minus 5, right? And for the x-intercept to be 13 by 2, okay, what we needed was something that, when we plug in y is equal to 0 and we bring this value over here, instead of 5, this should be 13. And this is only possible if this was 13, right? Um, yeah, in that case, let me just, okay, I've noted your question, and let me just quickly finish the solution. Okay, let me finish this question. Okay, so how we got 13 is because we want 13 in the numerator of the new x-intercept. We said that this is our original x-intercept, and we want to shift this intercept, to the right. So we want to move, along the x-axis to the right by 4 units. Okay, so if, for example, you were on a number line, okay, if you were on a number line and you were standing at 1, and I told you to go 3 units to the right, where would you go? You'd take 3 steps, okay? You'd go 2, you'd go to 3, and you'd go to 4. So what you've done is you've started from this point, point A, and you've taken 3 jumps and you've gotten to point B. So this is your new position. So over here, you've shifted 3 units along this number line to the right. Okay. Okay. So in a similar fashion, what we are doing over here is our original x-intercept was 5 by 2. Okay. And what we wanted was we want to shift this 4 units to the right. Okay. So just imagine that you are over here at 5 by 2 and you want to shift that 4 units to the right. So what we're going to do is we're going to take this value and we're going to add 4. Okay. And if we were moving to the left, we would actually subtract 4, okay, along the, x-axis. So what we did was we added 4 to 5 by 2 and we got 13 over 2, right? And now if we looked at this original equation, what happened was once we plugged in y is equal to 0 and we moved this value, originally number 5, minus 5, we moved this value to the left side, we got a 5, okay? But instead, over here, we want a 13, all right? So instead, if there was a 13 instead of a 5, if we moved it over here, we've gotten a 13. So let's say we just plug in 13 over here, okay? And then we've got 2x. Now, if we divide both sides by 2, we got 13 by 2 as our new x-intercept, which is the one that we needed, okay? And what is the equation of this new shifted line? That is 2x minus 13. But the question isn't complete. What did the question ask us? The question asked us that we are supposed to find out the new y-intercept of the shifted line. So all we have done is only so far find the equation of the shifted line, all right? We have found the equation of the shifted line. So now how do we find the new y-intercept? We plug in 0 over here. So y is equal to minus 13. And this is your new y-intercept. Okay. Yeah. Why did the y-intercept become? Because, when we're shifting this line, okay, this is a straight line, okay? And if we bring it over here, okay, notice that the y-intercept is also changing. So this was the first y-intercept, and now then we change, the y-intercept also changes. So when you're moving the, when you're moving the line left or right, up or downward, both the intercepts are going to change. Focusing on one intercept is going to help you find the equation for the shifted line. And then you can do whatever is being asked of you. So for example, in this particular case, what we did was we started by finding the x-intercept for the new line, okay? And we figured out the equation for the shifted line just by finding the x-intercept. But the question asked that, okay, you've been given this line, shifted 4 units to the right. We did that. We find out the new equation using the x-intercept. And now finally, the question that we needed to answer was, what is the y-intercept of this new equation? And that is y is equal to minus 13, okay? So this is where we are plugging in. So, how do we find the x and the, the x and, y-intercept is that if you're given an equation, y is equal to mx plus c, the way we find out the x-intercept is by plug-in y is equal to 0, and the way we find out y-intercept is by plug-in x is equal to 0. Okay, so I hope that some of the questions have been answered. Okay, and I want to move forward so that we can cover some of the other topics. And in our next session, we want to jump towards some of the examples. Okay, I hope this is clear. Okay. So now, let's say we're given a line. Okay, it's all about the lines for now. So we're given a line, okay, any line. Okay, so first of all, this line, looking at this line, we know two things. First of all, m is greater than 0 because this is rising, and c is also going to be greater than 0. Why? Because the y-intercept is, above this origin. So it's going to be, if I say that what is governing equation for this line, whether this is minus 3x plus 5 or y is equal to 3x plus 5, we would actually say, just without knowing whether this graph is drawn to scale or not, we can just look at this and find out that because the slope is positive and the y-intercept is positive, so yeah, this is the equation that, that is, suitable for this line and not any other line. Okay, so now what we were coming to is, if we have a line and we want to find out whether a point, lies on a line. Say we have got this line, y is equal to mx plus c, and we given this point over here. Okay, a is any point which has the coordinates x1 and y1. We don't know where a is. Okay, we don't know where a is, and we want to find out whether this point a lies on this line, and we're not shown this on the figure or on the graph. We are only given the coordinates for this. So what we do is we plug in, these two coordinates inside this equation. How do we do that? Is, for example, instead of x, we plug in x1. Okay, so I'm just going to write out. So instead of x, we plug in x1, and instead of y, we plug in y1, and we see whether the resulting equation is satisfying itself on both sides. Okay, how so? Because c is already a constant. This is just a variable that I'm showing, just to give you the generic nature of an equation. But otherwise, for a specific equation of a line, both of these things, these are constants. Okay, these are going to be numbers like y is equal to 3x minus 2, or 2x plus 7, something like this. So you're given the c and you're given the m, right? Yeah. Okay, so but if you're given a point and you were asked whether this point lies on a line, all you need to do is plug in x coordinate instead of the x value and the y coordinate at y position, and you're going to find out. So let's quickly do that. We have this equation, y is equal to x plus 3. I'm starting, simple so that we can all, follow this. And we're supposed to find out whether, 7 and 9 lie on this equation. How do we do that? Okay, so instead of x, we plug in 7. And instead of y, we plug in 9. Okay, so 9 is equal to 7 plus 3. So 9 is equal to 10. Does this equation satisfy? This does not satisfy. So this tells us that this point does not lie on this line, right? Correspondingly, if I were to find out, say, I was given a point 1 and 4, all right? Does this lie? Let's quickly plug that in. Y is equal to x plus 3 is our original form. The point that we are given is 1 and 4. And what we're going to do is plug in 1 over here and 4 over here. So 4 is equal to 1 plus 3. Do both sides of the equation satisfy? Yes, because 4 is equal to 4. So yes, this point lies on this line. Okay, so anytime you're supposed to you ask, or you're supposed to find out whether a point lies on a line, all you need to do is substitute the values in the equation of the line and see whether the equation is satisfied. If the equation is satisfied, the point lies on the line. If the equation does not satisfy, the point is, sorry, I don't know. Could you please repeat your question? I might have missed that during the chat. Okay. No, sorry. So I misread the chat. So we ignore, no, we don't ignore M. Over here, what happens is your M for this equation is equal to 1. Okay. Okay, just let me quickly do another example with an M which is not is equal to 1. So if you find an equation where it is written y is equal to mx plus 3, do not assume that we are ignoring M. We are not ignoring M. The value of M in that case is simply 1. So if we have this equation x plus 3, over here the M exists, but because M is equal to 1, so this is 1 times x, right? So we're not really ignoring M. We know that M is equal to 1. So any number multiplied by 1 is always going to be the number itself. Okay, let's quickly do another example. Okay, so y is equal to 2x minus 7. Okay, and let's find out if a certain point, so for example, 2 and minus 5 lies on this line. Okay, let's just quickly do that now. Okay, so we plug in 2 over here and 5 over here, minus 5 over here. So minus 5 is equal to 2 times 2 minus 7. So minus 5 is equal to, 4 minus 7. So minus 5 is equal to minus 3. No, this point does not lie on the line. Okay, so whenever we are supposed to find out, I'm just going to repeat quickly, whenever we are supposed to find out if a point lies on a line, plug in its coordinates in the equation of the line, and you're going to find out whether, if the equation is satisfied, the point lies on the line. If it doesn't, the point does not. Okay, right. Moving on. Okay, and this is again, a very interesting part of the lines. Okay, here are 2 lines. Okay, this is your first line, and this is your second line. And we want to find out, okay, let's call this as y is equal to, say, x minus 3. Okay, and let's call this as y is equal to minus x, okay, minus x plus any value, say 5. All right, or let's call it y is equal to minus 2x plus 5, so that we cover both the unity aspect and the non-unity aspect. Okay, so this line, the green line, has the equation y is equal to minus 2x plus 5. All right, and the blue line has the equation y is equal to x minus 3. And we are supposed to find out the point, this point, let's call it A, and we are supposed to find out the point A, or the coordinates for the point A, where the 2 lines y, let's call this as L2, okay, so that we can differentiate between the 2 lines. So where these 2 lines, L1 and L2, intersect with each other. Okay, so we've got L1 is equal to y is equal to x minus 3. Okay, and L2 is y is equal to minus 2x plus 5. Okay, and what we want to do is we want to find out where these lines intersect. Okay, so let's look at this point of intersection over here. What is, just think about it really quickly. What is the common thing at this particular point over here? Partially? Okay, so let me just quickly help you with this. Okay, yes. So at this point, because at the point of intersection, what is going to happen is both of the lines are going to have the same coordinates when they're passing through the same point. It is a point of intersection because both lines are passing through the same point. Okay, so if A has coordinates x1, y1, this x1, y1 is going to lie on this line as well as on this line, right? Yes, they are in quadrant one, but we're not really discussing the quadrants. We're discussing, about the point of intersection and what are the properties of the point of intersection over here. Okay, so x1, if this point has coordinates x1 and y1, this point is going to lie over here on this line L2, and this point is also going to lie on the line L1. All right, and then, okay, the question remains, how do we find out the coordinates for this point? If we have this point A, how are we supposed to find out the coordinates for this line? Okay, how do we usually, in the previous slide, just before this, in the previous slide, what we wanted to find out was whether a point lies on a line. All right, and what we did was we plugged in, the coordinates of the points at those points. In the line instead of y and x, right? So let's do that. And I'm just going to take a slightly longer approach just to help you understand, okay? So if A was, lying on this line and on this line, so you're going to get, for example, for L1, you're going to get y1 is equal to x1 minus 3. And for L2, you will get y1 is equal to minus 2x1 plus 5. Why? Because we have simply plugged in these coordinates. Just consider them as numbers. These are x1 and y1. These are variables. Okay, that's wonderful. If you have solved it, that's great. And I want to do that for the rest of our participants as well. So what we want to do is we want to consider both of these as numbers. These are just numbers. We don't know what they are, so they are variables. So plug in these. So we've got y1 is equal to x1 minus 3, and y1 is equal to minus 2x1 plus 5, right? See, here's the two things. Both this equation and this equation have x1 and y1s, okay? So we can do two things. We can either isolate x1 on one side such that all the other elements of the equation lie on the other side, okay? And do the same thing over here, and then solve for x1 because, and then equate these two. Or we can do that already because y1 is already isolated on the left side of the equation. So what we do is this is y1 and this is y1. So both are y1. What this means is x1 minus 3 is equal to y1, and minus 2x plus 5 is also equal to y1. So in effect, x1 minus 3 is equal to minus 2x1 plus 5, right? Yeah, you can do that by solving simultaneously as well, or you can simply equate these two equations, and that might be slightly simpler. So let's do by, the substitution method so for example, just by equation by substitution. So how do we mean substitution? So y1 is equal to x minus 3, right? Plug in this value instead of this y1 over here, okay? So let me just write that neatly. y1 is equal to x1 minus 3. And y1 is equal to minus 2x1 plus 5. And we plug in this value of y1 over here. So x1 minus 3 is equal to minus 2x1 plus 5. Now we've got one equation in a single variable, which is x1. All right, so let's do that. So we bring all the entities with the variables on other side and constants on the other side. So we bring minus 2x1 over here, and we take minus 3 over here. So this is going to be x1 plus 2x1. And we bring in minus 3 over here, so it's equal to 5 plus 3. And now we've got 3x1 is equal to 8, right? So 3x1 is equal to 8, right? And if we divide both sides with 3, so you'll get x1 is equal to 8 by 3. Absolutely. You can use simultaneous equations, any form that you want. substitution, elimination, you can solve this as a system of equations, works both ways. This is perhaps the simplest way, by substitution. Okay, so x1 is equal to 8/3. Wonderful. We find out this part of the point. Okay, but then how do we get y1? So if you look at this equation over here, y is equal to x minus 3. We understand that this point lies on this line, all right? And because at exactly this point, what is the value of y going to be? Let's plug in this value. So y is equal to 8/3 minus 3, right? So we take the LCM, which is 3. So 8, and 3 times 3 is 9. So 8 minus 9. So y1 is going to be equal to minus 1/3. 1/3. Okay. So the coordinates for point A are, A has the coordinates 8/3 and minus 1/3, right? So there's probably some mismatch between, the figure of this equation, because, the y-axis or the point of intersection, or the y-coordinate of the point of intersection should be somewhere over here. Okay, so, because this figure is not really drawn to scale, I, should be more careful. But what this tells us is how we can find out the intersection of lines. Sorry, as I said, I'm the choice of equations might have been, slightly misappropriate for this particular graph, but I just wanted to show how, the intersection point of lines are being calculated. Okay, so today we have discussed, so for example, 3 new things. So first of all, we discussed how we're going to shift lines. Okay, we're going to shift the lines. We can shift the lines along the x-axis upwards or down, along the y-axis upwards or downwards, or we can shift the lines along the x-axis rightwards or the leftwards. But the important thing is that both the intercepts change. When we are shifting the line along the y-axis, the y-intercept changes, yes, and it is easier to maybe calculate, but the x-intercepts also changes. And once we found out the equation for the new line, we can always go back and calculate the x-intercept for the new equation, okay? Then we discussed how we can find out whether a point lies on a line or not. And we can do that simply by substituting the coordinates of the point in the equation of the line. And we see that whether the equation satisfies on both sides of the equality sign. And if it does, the point lies on the line. If it doesn't, that means that the point isn't on the line. And finally, what we did was to understand how we can find out, a point of intersection of 2 lines, okay? And so let's say if we have 2 lines which are intersecting each other, okay, first of all, you have to look at, there are some questions which will also trick you. But for example, if 2 lines have the same slope, it doesn't really matter, unless they're collinear. We're going to discuss that later. But unless they're collinear, means they're coinciding with them, with each other entirely, right? So if the slope is the same, that means both lines are parallel and they will not intersect. But if the slope is different, then how do you find out the intersection of 2 lines? We find that out by, you can find that out by substitution, by elimination, by solving this as a system of equations. What we have done over here is solve this by substitution. So what we did was we found out that we can, for example, understand that, the coordinate, the point is going to lie on both the lines. So we plug in, the variables for the coordinates, and then we found out, or we observed, that this is y1, this is y1. So this part of the equation is also equal to y1, and this part of the equation is also equal to y1. So what we did was we, simply substituted instead of y1, one equation. We could have gone the other way as well. So instead of x minus 3 plugging into this equation, we might have plugged in minus 2x1 plus 5 in that equation, but that wouldn't have mattered, because, it's y1 on both equations, okay? And then we solve this equation for x1, because now this becomes a single equation in x1, and we solve for x1, and we can plug it in either of these equations, because this coordinate lies, both of these lines pass through this coordinate. So, choose the simpler line, okay? Choose the simpler line. it's easier to solve. Less chances of you making a mistake. So we simply plugged in the value of x coordinate in this equation, and we found out what the y coordinate looked like, right? So this brings us to the end of today's session.